Hello guys, now we're going to work with potential and kinetic energy, which is TEAC 6.8. So this is a 6th grade TEAC. If we look right here, it says potential energy is stored energy in an object. Okay, so it's stored, that is stored in an object. Kinetic energy is energy of motion. So this is stored. This is in objects that are not moving yet. But the energy is there, and here is the energy of motion, energy of objects that are in motion. Now here at the bottom we have an example, and it says the most potential, or I'm sorry, label the diagram below. Include most potential, so we're going to label that as MP, most kinetic with MK, least potential with LP, least kinetic with LK, and then the 50-50 where I have 50 potential, 50 kinetic. So then right here on this one, always guys, label the one that is at the highest. Okay, at the highest point, that's where I'm going to have my greatest or my most potential. It's not moving yet, it's up there. So then right here I'm going to put most potential. So if this is my most potential, then that means that it's going to be my least kinetic. And that's going to happen at the very top. If you throw a ball up to the top, once it's up at the top, it's going to have that quick stop, and then it's going to return back to the ground, okay, through the force of gravity. So then at the very top, that's going to be my most potential, my least kinetic. Over here, the same thing, most potential, least kinetic. And then right here, as I'm going towards the bottom, just before I hit the ground or before I leave the bottom section, that's going to be my greatest kinetic, okay, or my most kinetic. So then this is going to be where I have the most kinetic energy, the most energy of motion, and my least, okay, my least potential. Okay, least potential, most kinetic. Think about whenever your parents are driving and they go down a hill, or when you get on a roller coaster and just before you get to the bottom, then back to go to the top, you feel that little drop on your stomach, showing you that you're going right there with the most kinetic energy, most energy of motion. Now when we're talking about halfway before we get to the bottom, then we're going to say right here that we have 50-50. 50 potential, 50 kinetic. Same thing right here before you actually make it to the very top. So then as we move from most potential, our potential energy decreases and decreases, and the kinetic energy increases. Right here we're both 50-50, and then we have most kinetic increasing and or kinetic increasing and the potential decreasing to having the most kinetic least potential. Right here the same thing, my most kinetic is going to decrease and my least potential is going to increase. So we're now I have 50-50. And then my most potential, my most kinetic continues decreasing and my most potential increases. So over here I end up with most potential and less kinetic. Now the same thing is going to happen with the next example. So then right here I have my, again, I told you guys to look at the very top. So this is going to be my most potential and my least kinetic. There's no motion at all right there. And then when I get halfway through, not here, okay, but I'm going to say if this is halfway through right here, then I'm going to say this is going to be my, and I'm sorry, right here, I guess they labeled it for us kind of like being halfway through. This is going to be my, and yes, because it doesn't go all the way to the bottom, right? So then this is going to be my 50 and 50. And then when I hit just before the bottom right here, before the little dip, or once I get to the actual bottom, I'm going to put right here most potential. This is where before we get that, or this is where we felt that little hitting at the bottom. This is going to be my most kinetic and my least potential. Okay, it's kind of like gravity took you all the way to the bottom. So from top to bottom, that's where you have the highest potential and the least kinetic in that situation. Now here, some of us get confused and we think, oh, as soon as I jump, that's going to be my most kinetic. my most potential and my least kinetic. No, we go up to the highest point. So in this case, this one's going to have the most potential and the least kinetic right there. And then as I get halfway through, so then halfway through is going to be here by the time I make it to this jump, because this one jumped up. And then we have right here at 3, we're going to have 50-50. This would be 50% from bottom to top and from top to bottom. So that'll be 50 potential, 50 kinetic. And then when I hit the bottom, that's where I'm going to say I have my most kinetic. So then right here, I'm going to have my most kinetic and my least potential. So there we go with potential and kinetic energy. Now let's go to the next one. So we skip page 51 because it's other examples, and I just want to go through the STAAR release questions for this section. So then right here it says on page 52, in the classroom demonstration shown below, a rubber ball is dropped from position 1. Okay, so we drop the ball from position 1. The ball bounces as shown. So let's look at the information that we have here, and it says, at which of these positions, so then at which position does the ball have both the greatest kinetic energy and the least potential? So I need greatest kinetic and least potential. So if we look at the ball over here, I'm going to have my greatest potential, least kinetic. And then over here at the bottom, I'm going to have my greatest, okay, this is going to be my greatest potential, my greatest kinetic and my least potential. So then if we look at this information, is asking greatest kinetic. So if we look here, greatest kinetic and least potential, and we wrote it here, right? So then when I look at this one, this is greatest potential, least kinetic. This is my greatest kinetic, least potential. So my correct answer is going to be at position 2. So it's going to be letter B. I don't even need to justify for the other ones. I already got my answer based on the information that I know. So this is page 53. So on page 53, I'm being asked for question number 22. The drawing shows 2 identical airplanes. So that means that they have the same mass, same everything at an air show. The airplanes are flying at the same speed. So same speed, same motion. Airplane W is flying 50 meters higher than airplane X. Okay, so then we have right here, airplane W is flying 50 meters higher. 50 meters higher, okay? And both of them have the same speed. So right here, I'm going to put same speed and same speed for X. Same speed. So it says, which statement best describes the energy of the 2 airplanes? So I want to describe the energy of the 2 airplanes. So let's look at the possible answers. Airplane W, which is over here, has a greater kinetic energy than airplane X. If they're going at the same speed, I have the same kinetic energy. So then right here, when I'm looking at this one, W having greater kinetic energy than X, I'm going to say no, they actually have the same. So I'm going to X that out. The 2 airplanes have the same gravitational potential energy, but different kinetic energy. You know what? They have the same kinetic energy. Now, when we're talking about gravitational potential energy, that one we're talking about gravity, guys. So then that means that the one that is higher is going to have the greater gravitational potential. So both of them do not have the same. It's actually different. Airplane X has more gravitational potential energy than airplane W. No. Now that we know, okay, greater gravitational potential, this one has greater gravitational potential. This one has less gravitational potential. So no, so then on this one, I'm going to say no. The two airplanes have the same kinetic energy. I like that. But the different gravitational potential energies. Oh, okay. They didn't even ask which one has more, but they're saying different. So I'm going to go with letter J as the best possible answer. This is page 54, and we're going to start, or it's actually just one question. Okay, question number 4. Let me go ahead and push this up a little bit higher so we can see part of the answers. This question takes up the whole page. So it says, 4 students were asked to classify the activities of the people in the picture below as examples of either potential or kinetic energy. So we're going to be looking at potential energy or kinetic energy. Remember, potential, that means that it's stored energy, and kinetic is energy of motion, of moving objects. So which student correctly classifies the activity or classified the activities? Student 1 says, girls swimming laps. So when we see the girls swimming, potential energy. It's not potential, they're already in motion. So then this one's not going to be it, just because of the first example. Sorry, I dropped my pen. There we go, I got it. So now we're going to go to G. Or you know what, let's go to H, since it's over here on the side. It says, girls swimming laps, kinetic energy. Yeah, they're moving their hands, so there's that kinetic energy. Boy on diving board, and we see them over here swimming, moving. Actually, it's over here, right, with the swimming. Boy on diving board. When we think about the boy on the diving board, the boy is way up there. Whoops, sorry guys, sorry. Things are moving over here. So then we have the boy on the diving board. So that is going to be potential energy. He's not jumping yet. He is on the potential energy. Okay, so then it says kinetic right here. Nope, it's potential. So this one's also wrong. So then we go to letter G. So I'm going to say this one's out. I'm going to go to letter G, and then letter G says girls swimming laps, potential energy. No, this is actually kinetic energy. It's energy of motion, so that's not it. Girls swimming, kinetic energy. Yes, they're moving. Boy on diving board, potential energy. Yes, it's energy of stored energy. Girl hitting the volleyball. So then hitting, they're moving their hands. So it is kinetic energy. Boy holding the volleyball, potential. So then right here, correct answer is going to be letter J. So this is page 55, and we're on number 25, still with potential and kinetic energy. It says a student drew the diagram below to show the movement of water through the hydroelectric dam. And then the possible answers right here. We do see here, let me see. We're going to go with the letters of the alphabet. So they're showing position W, position X, position Y, and position Z. It says the student used the diagram to describe the changes in the potential and kinetic energy of the water. At which location is the gravitational potential energy of the water the greatest? So then if we look at this example, guys, when we're talking about the gravitational potential energy of the water the greatest. Remember, first of all, when we're talking about potential and kinetic energy, we're going to say wherever I am the highest, that's where I'm going to have my highest potential. Least kinetic, when I'm at the bottom or going towards the bottom, I'm going to have my highest kinetic, lowest potential. So then right here, just by looking at the word gravitation, I'm thinking about gravity, potential, like gravity is holding me up. I mean, I'm being held, but gravity might pull me down. And right here, when we look at W, right here, this is where I'm at the highest point, okay? So this is at the highest point, and it's talking gravitational potential. And that's where I have my highest potential. So we're going to select letter W. Be very careful. Right now, I was looking for W over here. So that's going to be letter A. Okay, so here, Here we have, I'm sorry, this is page 56 from your review guide, and we're working with question number 15. So it says a roller coaster or roller coasters are popular attractions at amusement parks. A cart on a roller coaster approaches the highest point on the coaster as the cart reaches the top. Or as the car reaches the top, it slows down. Which statement best describes the energy of the roller coaster as it slows down while traveling to the top of the coaster? So I'm thinking about a roller coaster. So I am going to draw one right here, and then there's the top, there's the bottom, and there's another hill right there. So we're talking about the roller coaster before it approaches to the top. So I'm going to draw the little cart right here. So then this is the cart, the roller coaster cart. So then if I have right here, this is going to be my greatest potential. Okay, so this is going to be my highest potential, my greatest potential once I make it up here. So then when I was at the bottom, the little coaster continued. So then right here, and the question is again, which statement best describes the energy of the roller coaster as it slows down? So it's slowing down. So then right here, it's slowing down before it makes it up here to the top. Okay, so then the cart gains both kinetic and potential energy. Well, as it's going up, it's losing kinetic and it's gaining potential. So no, it cannot be that. It gains potential as it's moving up. The cart gains kinetic energy and loses potential. No, it's losing kinetic. Okay, it's the other way around. The cart loses kinetic, I like that, kinetic energy, and gains potential. Very good, I like this one. It's kind of like when we say it's going 50-50 and I'm losing potential and gaining kinetic, or gaining kinetic and losing potential. The cart loses both kinetic. No, it cannot lose both. One it loses and the other one it gains. So then the best possible answer for this one is going to be letter C. So this is still page 56. We are at question 14. So it says a demonstration helps students understand the principle of roller coaster design. And then it says a motion demonstration model. The ball mass is 2 kilograms. So it's the same ball. So then right here it says which answer choice correctly describes the ball's kinetic and potential energy. So we need to look at all of the possible answers to answer this question. It says the ball has more potential energy at position X. So then I am at X. Remember, my highest potential, and I should have done this right here before I started. So we're going to put right here, we have high potential, least kinetic. And over here, I'm going to have my high kinetic and my least potential. 50-50 right here, that would be here and here. So then the ball has more potential energy at position X. So the next, it cannot be high potential, okay? I am losing potential and gaining kinetic. And the lower I get, the more kinetic energy I gain. So that's not the answer. The ball has more kinetic energy at position Y. You know what? More kinetic energy. Yes, high kinetic right here. Then at position W. Of course, that makes sense. But I don't know if that's the possible answer yet. The potential energy and kinetic energy of the ball are equal at position X. No, it isn't. Equal is going to be right here at position W. So right here, I'm going to put, actually, it's supposed to be at position W. The potential energy and kinetic energy of the ball are greater at position Z. Nope, right here it kind of like changes. So then that would be always at the bottom, guys. So nope. So then kinetic energy ball are greatest at position Z. Nope, that is not it. So the correct answer is going to be letter G. So here we have page 57, and we're still with potential and kinetic energy. So let's look at question number 21. A marble is given potential energy by being placed. So a marble is given potential energy by being placed at location W. When the marble is released, it rolls down the track. So it's going to roll down the track. So they're telling us what's happening. So here I have my greatest or my highest potential, and this is going to be my least kinetic. Over here, I'm going to have my greatest or my highest kinetic and my least potential. So let's look at the possible answers. At which location does the marble have the maximum kinetic energy? Where did I put my maximum or my greatest or highest kinetic? It's going to be right here. Okay, so then I'm going to choose location Y. There. 7. So this is page 57. So we continue with page 57. We're looking at question number 7. And it says a bicycle rider is traveling uphill. When the rider reaches the top of the hill, so here we have the top of the hill, she stops to rest. Then she travels down the hill. The diagram shows the rider in the 3 different positions. So let's look at the 3 different positions right here. I'm going up, so my kinetic energy decreases. So then it decreases. And my potential energy is going to increase. Right here at the very top, I have highest potential and my least kinetic. As I'm going to the bottom, my potential now is going to decrease and my kinetic is increasing. So it says, which of these correctly describes the potential energy and the kinetic energy of the bicycle rider? When the rider is at the top of the hill, so at the top, potential energy is greatest, high potential, that is true. And her kinetic energy is the least. That is also true. I want to say that that's the answer. As the rider moves uphill, her kinetic energy increases. We said no, kinetic energy is going to decrease. So that's wrong. C. When the rider goes down the hill, her potential energy increases. No, we said potential energy decreases. Okay, so that's not right. Potential energy decreases. So here we go. As the rider reaches the bottom of the hill, her kinetic energy and her potential energy decrease. No, we said potential energy decreases. Okay, so then right here, potential energy decreases. It says her kinetic energy and her potential energy decrease. No, kinetic energy increases and the potential energy is going to decrease. It does not stay the same. So then the correct answer is going to be letter A. So this is page 58. Now we're working with energy transformation. Energy transformations. It says energy can change from one form to another. Complete the energy transformation diagram using the following forms of energy. So they want us to use light, chemical, mechanical, electrical, potential, and kinetic. So when I look at this one right here, we have a propane generator. So right here, when I look at the propane tank, I quickly think this is going to be chemical energy. These are chemicals. So then when I look at the generator, so then I go from chemical energy, the generator moves the motor, okay, so that the generator can produce electricity. So then we're going to have mechanical energy. Mechanical energy is the energy of objects, moving things. So moving parts, like me moving my fingers, that's mechanical energy. So then right here, I'm going to say mechanical because of the motor that needs to turn. So that's going to be mechanical. And then, of course, after the mechanical energy, and as it goes through the generator, then it's going to turn into electricity. So then it'll be electrical. Yes, here it is, electrical. Now, when we're looking at a flashlight, which is the next one, the next example, we have right here, okay, the flashlight, the batteries hold chemical energy. Think about chemicals that they have to put there to make it hold that energy. And then once we put the batteries in there and we close a circuit or we turn on the light, we say that we have electrical energy of those electrons. So then it's electrical energy. And then of course we see the flashlight turn on, so we say light. Now here it could also say heat energy, because after a while heat, or what is it, electromagnetic energy, the light energy that turns into heat. Over here after electrical or before electrical, it could be mechanical, and then it could be sound and electrical. Okay, now let's go ahead and go to the last section, the hydroelectric dam. So here we have energy, water at the very top, and we're creating energy. Water goes down and it moves the little motor, right, the little rotor, and then that rotor will make the little motor work, which the motor belongs to the generator. And then we have that electrical energy. So then we're going to say water over here, before they open the little opening for the dam, we have water that is waiting right there. So we say that we have potential energy, potential gravitational energy. And then that potential energy, once the water is moving down, we say that it's kinetic energy. And then after that, it goes in, the water moves the little blades to make the motor, the generator work. So then we say that it turns into kinetic. But here we're not going to put kinetic, we're actually going to put mechanical, because now we have things that are moving mechanical. So the water makes that little things move right here, the blades, and then those move the generator, and the generator starts creating electrical energy. So from mechanical to electrical. And there we go. That's a quick review of energy transformation. This is page 60, and I'm just going to go over a quick review of what we have, just the main things that you need to know. So these are also practice information. But what I want you to know from right here, guys, is that right here we have the wind. So we have wind energy, and then we have the blades move with the wind energy and they go around. So because of that, we call it mechanical energy. So when the blades are moving, we call it mechanical energy. And then we have right here the energies, the blades are turning, and because of that, they're turning the generator. So then right here, it continues mechanical. Now, once the energy goes through the generator, and then it goes after the generator, then we say that it turns into electrical. So right here, it would be mechanical. Right here, the little turbine is turning on the generator. So that would still be mechanical, because things are moving, mechanical. And then after the generator, once he goes out, then it's going to be electrical. And of course, once it makes it to school, we can say that we have that light that is going to help us see. If someone's using the microwave, then we say that it goes from electrical to the microwave, which are some type of waves from the electromagnetic spectrum. So we said electromagnetic radiation, depending on how it is that they're asking you that question. The same thing right here. We have the water, which is in the boiler. So then from right here, we can say that it goes from chemical. So then right here, we have water heated and turns into steam. So then this one we say that it's going to be chemical. It goes into the boiler. So then we have mechanical, because it's going to be moving. And then we say mechanical because of the turbine. And once it continues through the turbine, mechanical, so then it goes into the generator. And then after the generator, it is going to be electrical. Okay, so then it goes from thermal, thermal energy, it's hot, to mechanical, to mechanical, to mechanical, and then to electrical. Okay, so it's thermal. I don't know if I said chemical. No, it is actual thermal, because we're talking about heat and steam. This is page 61. So now we're with energy transformation. It says the diagram below shows a hot air balloon rising. Propane gas. Right now when I see propane, I already think, you know what, this is chemical. So propane gas tanks are seen at the bottom of the balloon. So I see the propane tank, and I'm going to say this is chemical. and then the flame, which will be heat, and then the motion of the object moving up, I'm going to say mechanical. I'm not sure, but let's see. What energy transformation occurs when propane gas is used to lift the balloon? I go from chemical, so I quickly remove the mechanical because there's not going to be any motion on the object or any of the moving parts, which is the balloon and its whole system. So then I'm going to get rid of mechanical. I'm going to say that it's not thermal to begin with. We start with chemical. So I'm going to go chemical. And then it won't start moving until that thermal heats up the balloon so that the balloon can go up, and then mechanical. So then the correct answer is going to be right here. It says thermal to chemical. Okay, no, it's the other way around. And this one we had already said no. So the best possible answer is going to be the letter D. The propane, we have the heat, and then we have the moving up of the object. Now let's go ahead and go to the next one. This is page, this was 61. This is page 62. So on page 62, we have question number 3. So let me fix right here question number 3. And I said that we were on page 62. So for page 62, it says, the main parts of a working clothes dryer are shown on the diagram. So then we have a heating duct and element. We have a motor. We have the drum. This is where the clothes goes in and moves around. And of course, without this, we couldn't do it, right? So then it says, which is the plug, which is the electricity. It says this appliance dries clothes primarily by converting. So we have electrical right here. That's going to be my first one, electrical. So then electrical, it cannot be mechanical. It cannot be mechanical. So I'm going to go with 2. Electrical energy to heat. It says that first it heats up and then it moves. You know what? Let me check the other one. Electrical energy to heat and then light. Okay. So then if I look at this, electrical energy to heat. Okay, and mechanical energy, so we're talking heat and moving, that might be it. Right here it says electrical energy to heat and then to light. We're really not looking at the light, even though it happens when you open the door, but we're looking at the heat and the mechanical when the drum moves around. Okay, so the electrical helps produce heat, and then the mechanical, which is going to be the motion of the drum right there. So then my best possible answer is going to be letter A. Right here where they threw in the light, think about, you open the door just to take out, you need the light just to take out. It's not for the purpose of drying up the machine, okay? And it says primarily, so we're looking for what the purpose is. For number 35, it says a teacher rubbed a match against a piece of sandpaper. So then we're rubbing the match. Okay, scratching it. The match started to burn. Which statement best describes the energy changes that occur? First of all, think about a match. More than likely it's going to be chemical, right? So then the chemical energies. So then right here it says the thermal energy. And you know what? Before I start removing like the other one, like the previous question, let me go through each one of them. The chemical energy stored in the match changed to thermal energy and then to light energy. I kind of like that one. The thermal energy stored in the match, there was no thermal energy. There was chemical energy. So no. The light energy and thermal energy stored in the match, there was no light yet. Okay, there was no thermal yet. Okay, until it got scratched. The light energy and the thermal energy stored in the match, nope. So then yes, the best possible answer is going to be letter A. Let's go to page 63. Okay, page 63. On page 63, let me put it up here. 63, there we go. So then it says question 24. This one looks kind of small for us to read. So let me go ahead and I'm having trouble with my, there we go, with my apparatus that we had to get, which conflicts, but that doesn't matter. Okay, so then 24, it says students build a circuit. Remember, the circuit is when you put the little wires in the battery and then you put a little light bulb or a little motor to make it work. We used to do this in elementary, guys. So then students build a circuit. The circuit has wires that connect to a battery, to a switch, and a fan. So which energy transformation happens? So which energy transformation happens when the students close the circuit and the blades of the fan begin to spin? Remember that I said right now, when you close the circuit is when you put all of the things together. So we have the battery. So these are the batteries. And then right here, it makes up the flashlight, right? The little light bulb is already there. And then there's a switch. The switch, when you close it, it's kind of like you're making all the connections touch. When it's open, that means that there's a little gap between the connections. So you got to close the circuit to make the flashlight turn on. So then we go from chemical, because it's coming from the batteries. So I like that. To mechanical, because we're moving the little switch. So you know what? Maybe. And then to electrical. Okay, sounds good. Maybe. We get from electrical. No, we need the chemical before we get the electrical because of the batteries. Okay, from the chemical, okay, to electrical. Okay, chemical to electrical to mechanical. You know what? We are talking about a fan, right? So then right here was chemical to mechanical to electrical, but then where's the little fan? So then right here, chemical, batteries. So we don't even need to think about the switch. To electrical, the batteries, chemical, batteries, electrical, the electricity, and then to make the little motor move. I like this one better than this one. So this one, it has a thumbs up. Mechanical energy, no, there's no motion right there at the beginning. It's chemical. Chemical to mechanical. Oh, I guess we were not talking about the switch right here. We were talking about the fan. Fan cannot turn on. There we go. I went and double checked my work, and I figured out, or I determined, right, based on the information, that yes, I go from chemical, the batteries. Then the batteries, when I turn on my switch, it goes into electrical, and then it goes into the motion of the fan. So then my correct answer is going to be letter H. Okay, and once again, we have the battery, and then I have the electrical, and then we have the fan moving. So letter H. Let's go ahead and go to the next one, which is number 4. And I cannot see all of the information. Let me go ahead and see right here. There we go. And let me push this up. So then it says, which statement? Let me see if I can get this one. There we go. Well, I can see a little bit more. It says, which statement describes the energy changes that occur when water in a tea kettle is heated on a stove that uses natural gas? Natural gas, I'm already thinking chemical energy. Okay, so then some of the chemical energy in the natural gas, okay, so that is good, transforms into thermal energy, okay, which heats the water. Then some of the thermal energy changes into sound energy when the water forms the steam and the steam leaves the kettle. And we see the steam leaving the kettle and making that little whistling sound that it makes. So then this one sounds very good. Chemical energy into the heat, okay, which heats the water, and thermal energy changes into sound. Okay, so then heat to sound, or thermal, since they're using the term thermal. So I like this one. And then right here it says, some of the thermal energy in the natural gas, there's no thermal energy in the natural gas. Some of the electrical energy in the natural gas, there's no electrical energy in the natural gas until the gas, okay? And this one wasn't even electrical. Some of the light energy, whoops, let me go to the bottom. I'm glad I looked at the screen. So some of the light energy in the natural gas, there's no light in the natural gas. So the best possible answer is going to be letter F. So we're on page 64. So right here, page 64. This will be the last page of the section. So let's go ahead and look at the information. This is question number 26. So it says the blades of the wind turbine are at rest until the movement of the air causes the blades to spin. So then the movement of the air are going to make the blades spin. So here's resting, here's the before, and here we have once it's spinning. So then right here, which energy transformation happens when the blades are spinning is shown. And remember that we said before, once the blades spin, because of the wind energy right here, then it'll make the blade spin and the little generator will turn. And then once that generator starts turning, it starts producing electricity. So then right here, let's see what we have. Electrical, no, it's not electrical yet. To mechanical, no, it's not the electricity, it was the wind that was moving the blades. Chemical to electrical, no, it was wind energy, was not chemical. Mechanical to electrical, and you know what, right here, mechanical, the wind moves the blades. The blades start moving, and then we have electricity. I'm gonna put a question mark. Chemical, there was no chemical. Okay, so I cannot say right here that I start with electrical because there was no electricity before. Chemical, there's nothing chemical, so I get rid of those two. I do know that the wind moved the blades spun the little generator motor, and then we had the electrical being produced. So letter H is going to be the best possible answer. So let's go ahead and look at the last one. And for the last one we have, let me make it a little bit closer right here. There we go, so we can see it a little bit better. So then this one's question 1, still on page 64, and the last one, okay, on page 6, the last one for the whole video. It says, a cook heats a meal in a microwave. So we're heating up a meal in a microwave oven. What energy transformation occurs between the microwave oven and the meal? So we're looking at the microwave oven and the meal. So we have the microwave right here. And then we have the little meal in there. So this is the meal. And we see some little smoke right there. So it says from electrical energy. So we have electrical energy, light energy to chemical energy. Right here, there is really, it says between the microwave and the meal. Okay, so we could say that there's electrical energy. So that's good. Then there's light energy. And then there's chemical energy. Well, if we're talking about the meal becoming chemical energy before I eat it, I'm not sure. Let's go to see if there's the best one. We have chemical energy. No, it's not chemical energy. It's actually either electrical or, right there, electrical, right? Because the microwave's plugged in. So then electrical energy to electromagnetic energy, and you know what, light energy, the motion of those molecules and all of that, they're the ones that are heating the energy, and then thermal energy. So then right here, if we think about the electromagnetic spectrum, when we're talking about that light energy waves, this one makes more sense, that the light is not heating up the food. So then right here we say electromagnetic and then thermal energy to heat up the microwave. Chemical energy, no, it's not chemical, it's gotta be electrical. So then from these two, the best possible answer is going to be letter C. Thank you guys. Complete these questions and we should be able to do well on the STAAR test. Thank you. Enjoy the rest of the day. Take care and stay safe. Bye-bye.